Hi guys and girls, me again. Today we are going to do some integral geometry, which is just a fancy way of saying that it's made up of shapes that are formed by integrals. As you see in red, all we're going to do is find the area of the shaded bits of each graph, and I've got 3 for you to have a look at. So for the first one, we are bound by our x-axis, we are bound by the curve, but we need to know where these 2 points are. We're going to do that by solving the quadratic. So quadratics have to be equal to 0. Don't particularly like the negative in front of the x squared, so I'm going to multiply through by -1. And then factorise. Giving me that x is 4 and -1. So we've got -1 there and a 4 there. They become the limits of our integration. So we are integrating between -1 and 4, the equation, which is -x squared plus 3x plus 4 with respect to x. See my notes where I was working out the answers beforehand. Anywho, we integrate, we add 1 to the power, so that becomes 3, and divide by it. It's -1/3 x cubed. Second term, add 1 to the power becomes a 2, divide by it becomes 3/2x squared, and add 1 to the power on the 4 becomes a 4x. Now that means I'm going to substitute 4 and -1 into there. If you substitute the 4 in, you're going to get 4 cubed is 64, so -64/3, plus 4 squared is 16, times 3 is 48, divided by 2 is 24, and 4 times 4 is 16. And if you sub the -1 in, we're going to get a -1 there, so times by that gives me +1/3. -1 squared is a +1, so that's a plus 3/2 and a -4. Now you can shove it all into your calculator if you wish. You end up with 13.5 to 3 significant figures. Take you on to the second one. Looks very, very similar here in the sense that it's a quadratic, but this time our area is below the axis, which means we are going to get a negative number. So, same process. Find the 2 points of intersection with the x-axis. So solve the quadratic. And this one's nice and easy because it factorises straight away to a -4 and a -2. Which means that x is 2 or 4. So we are integrating between 4 and 2. The equation, which is that with respect to x. So add 1 to the power becomes a 3, divide by it's a 3rd x cubed. Add 1 to the power is 2, divide by it is 3x squared. Add 1 to the power becomes 8x. Evaluated between 4 and 2. Now sub in the 4, so 4 cubed is 64, divided by 3 is 64/3. Negative, and 4 squared 16, that is 48, and 32. Sum in the 2 squared, 2 cubed, sorry, is 8. Then what are we doing? 4, 3 is 12, and plus 16. And again, you could work that all out in your calculator. You end up with -4/3. So the area is 4/3. And the negative just tells me that it's below the axis. Okay, last one. Now with this one you've got a bit that's above and a bit below. So if you just take those two limits on the outside, you're going to have some of the limit that's above, or the area, sorry, that's above, cancelling out some of the area that is below. We don't want that. We want to work out the area below, the area above, and add them together. So we're going to do the integral and then do it between two different sets of limits. Okay, so still need to solve it, still need to find these three roots. So again, set it equal to 0. Don't particularly like the negative, so multiply through by -1. Now they've all got an x on, so you can take an x out as a factor, which will leave you with a quadratic, which will solve rather nicely into a -3 and a -4. So the 3 points are 0, 2, and 3. So the area that's below the axis will evaluate between 0 and 2, and the bit above between 2 and 3. Right, so we take the area that's below the axis first. Actually, what we can do is we can just integrate it without any limits first. And then we'll put the limits on after. So if we integrate that, we're going to get 4, so -1/4 x to the 4, plus 5/3 x cubed, minus 3x squared. So I need to evaluate it between the limit for the lower ones, and then add on the limit for the upper one. I missed a term. So first of all, it was between 2 and 0. And then I'm going to do the same thing between 3 and 2. And then add my two answers together. Okay, so if we substitute the 2 in, we get 2 to the power of 4 is 16, divide that by 4 is 4, so -4. And then 5 times 8, so 40 plus 40 over 8. Take away 12. And when I sub the 0 in, all of those are going to be 0. That is going to give me negative... where is it in my notes? I've gone and lost it. 8/3. So the area of that is just 8/3. I'll come to that in a sec. Okie dokie, if I sub in the 3, I'm going to get 3 cubed is 81, so -81/4, plus 27 times 5 is 135, over 3, minus 9 times 3 is 27. Then take away, when I substitute 2 in, I know I'm going to get -8/3 because that's what I got up there. Okay, so that is going to give me, go back on my calculator and work it out, -9/4. Plus 8/3. There we go. That makes 5/12. So the area above the axis is 5/12, the area below the axis is 8/3. So my area is 5/12 at 8/3. That is 37/12, or 3.08 to 3 sig fig. Just make sure that if you are asked for an exact value, you do not turn it into a decimal. Okay, bye.